Welcome everyone. Thank you for joining us for today's webinar. My name is Agatha Walker and I'm the Marketing Manager at NVMA. I'm here to introduce you to our keynote speakers. We have John Hill, Chief Operating Officer at NVMA. John will introduce you to NVMA and this series of webinars. Our main speaker today is Steve Clarke, Chief Technology Officer from Wyld Networks. Previously a senior BBC engineer and lecturer at Salford University, Steve has many years of experience in software and electronics, from RF telemetry and the multi-award-winning tagged McLaren AV processors, to EPOS and smart energy meters as a senior member of the design team at Cyan Technology. He led the development team of venture capital-backed business ACIS, now VIX Technology, enabling them to grow to become the UK's largest bus telematics company into the Tech 100 index of fastest growing companies. John and Steve will be happy to answer your questions after the webinar. So I would like to encourage you to type your questions into the question box in your control panel. Now it's over to you, John.
Hello and welcome to NVMA's Hidden Factory webinar series. My name is John Hill. I'm the Chief Operating Officer of NVMA. And before I introduce you to our guest speaker today, I'd like to just explain to you a little bit about NVMA and who we are, the background to the webinar series, and also what you can expect to get value from the series as you look through and probably look at the other webinars that we have on offer. So first of all, about NVMA. Our purpose is to connect the physical and digital worlds to transform industry. And we do this by using technology, solving problems, and driving change. What makes us unique is that we have a deep sector expertise and track record in the industrial market. We have an end-to-end industrial transformation capability from strategy consultancy through to control systems integration. We have an extensive ecosystem of partners. They include PTC with their ThingWorx and Vuforia Studio, Microsoft Azure, ARM for connectivity, Dell for gateways and hardware, and we also have our service partners of DMS and Sensei. The other thing that makes us unique is our flexible products and services. We have our Asset Minder product, which enables you to rapidly get to value in your digital transformation or smart factory implementation. And our services range from a simple discovery workshop to expose you to the new technologies that may impact your business, through to a strategy workshop with your senior leadership team to identify where the best bets are to place with the new digital technologies. A design and implementation workshop, which looks at how and what's the best ways of implementing in your specific situation, followed by our more traditional application development and system integration services. And of course, once you have done the implementation, our support package and service level agreements to help maintain the savings and investments that you've made. Why did we decide on raising and starting this webinar series? Well, bluntly, it's because digital transformation is happening now. Recent study by PwC showed that 90% of industrial companies are investing in digital factories. 70% of companies consider digital manufacturing at the top of their operation strategy agenda, according to McKinsey. And indeed, in the United States, the National Association of Manufacturers have made the statement that industrial companies need to capitalize on digital technologies to defend and advance their competitive advantage. Indeed, the World Economic Forum have found that those companies, the lighthouse implementations, as they call them, yield a huge impact. And they've reported double-digit KPI improvement in areas from factory output increase to productivity, to OEE, to product cost, time to market reduction. And indeed, the Standard & Poor's have noted that failure to act and make digital implementations over the next 10 years, half of the people in the Standard & Poor's 500 firms will be displaced. Most companies fail to move to this stage of scale and capture value at scale. And McKinsey in 2018 identified that in large factories, there were up to 8 digital transformation related pilots running in each one of those factories. but only 25% of those succeeded. 75% of those failed to go on to deliver any continuing value. And that's why we set up the webinar series. What we're trying to do is, through our demonstrations of maybe the technology and our approaches, but more importantly, presentations from our partners and our customers who are going through this process or have delivered on these processes right now, will prove valuable to our other potential customers and current customers. Thank you very much for listening to this. And now I'm going to introduce our speaker.
Welcome to today's webinar, brought to you as part of the NVMA Hidden Factory webinar series. I'm Steve Clarke of Wyld Networks, and today I want to talk to you about connectivity for the factory floor. Particularly, I want to cover the emerging technologies in data communication, including LoRaWan and Bluetooth and many other networks such as mobile, NB-IoT, satellite, even mesh networks. So just a quick piece of information about Wyld. So Wyld Networks formed in 2019, and we specialize in connectivity for difficult to reach places. That might be where there's no network availability, so you're in a remote place or a place which is a difficult radio environment, or it might be in a stadium when there are so many users that actually getting access to that network, getting any capacity on that network is really hard. So we're part of the Turn Group based in Cambridge and Brighton, and we specialize in the LPWAN and mesh networking technologies for connectivity. And though we're quite young, we have already nearly 500,000 devices using our technology out in and around the world. So when we think of connectivity in the factory, we think of wires, traditional way of connecting things, very cheap, reliable, relatively low cost in terms of the copper, and it gives us a known connection. We can connect it on wiring diagrams. We have complete control of that. What we have now is really mobile connectivity that is becoming reliable and copes with the much more complicated data environments that we have, particularly suited for areas where actually wiring up is really hard, and any reconfiguration of a workspace of a factory is complex, takes time, takes cost, and is very disruptive. So by augmenting this with wireless connections, particularly with low power, low cost, remote devices, we can add in, we can augment, we can potentially make things more reliable than the wired network. And I think if you look around your home, look around offices, around factories, you'll see that wireless really is part of the fabric of our workplace. And we trust it much more than we might have done 10 and certainly 20 years ago. So the future is here, and the future is noisy. We've often heard about the 50 billion devices that we are to have by 2020. Well, we see many statistics for this: 20 billion, 50 billion, 75 billion, some large number. Look around your house. I counted around my home the other day, 25 wirelessly connected devices, all operating in the ISM band. They're not all internet enabled, but most of them are internet enabled, and mine is not an atypical home. If we add in all the other much dumber devices, things like your doorbells, your car key fobs, and other small devices. We are very wirelessly connected, and that means a lot of users in a very small space. So there's a lot of radio traffic. We have standards, we have wireless connection methods that will work within this. So even if we look at, say, in London, we might have 100,000 devices within a square kilometre. We can still make all these devices work together and work successfully and reliably. So wireless is pervasive. When I talk to people about connectivity, typically they'll go, well, it's a SIM card, and that's how I get my data. What type of SIM are you using? And that's the thing. Wireless has traditionally meant that we can get either mobile data connections using Vodafone and EE and all those people using typically GPRS and 3G, and those are our expensive data applications, our high reliability applications, our distant applications. Or if we want much higher data rates and we don't want to pay for it, then we're going to use Wi-Fi. And there's a lot of congestion in Wi-Fi networks, and we don't really like that as connectivity unless we have to. But we have many other standards available now, many other methods of connecting our radio devices into our network, some of which are particularly reliable and designed specifically for the industrial space. What we're finding is that the mobile bands have transformed. We're now looking at really sort of 4G and 5G applications, some specific IoT applications. And we're looking at what they call the ISM band, instrumentation, scientific and medical bands, for our low power, long range and freely available data links. One thing is clear, the wireless world is changing, and relying on our existing connectivity is not certain. And one of the things that we must all be conscious of is 2G and 3G networks around the world are being turned off. So if we look at what the sunset plan for the operators are, is that already in some parts of the world, 2G has already been removed. So for example, Australia has got rid of just about all of its 2G networks. There's plans for getting rid of 2G and 3G throughout Europe, and in America, we've already lost many of the 2G networks. So we can't assume that we can keep connecting via 2G and 3G for all our data connectivity. If we look at what are the capabilities, so the big trade-offs are always data rate and range. And as a radio engineer, people ask me, well, how far will this go? Or how fast will it go? How much power will it use? I've tried to simplify a little bit the capacity and the range of the networks. It really is a simplification, but it should give you some idea of the range of devices that you have, the range that they will connect, and the range of data rates. So we have our local area devices, our Bluetooths, our BLEs, our Zigbees, our wireless hearts, and things like that. We have our mobile connectivity, the cellular 2G, 3G, 4G, 5G, with its various protocols. And then we have our long range, low power, wide area network connectivities, in particular Sigfox, LoRaWan, NB-IoT, Cat-M1, the ones that are focused very much at IoT applications. We have a variety of options available to us. Some are quite old. So if we look at, for example, wireless meter bus, which is probably the most prevalent of these standards for connectivity available now, through LoRaWan, Bluetooth, the new cellular communications connectivities, and they occupy different spaces. We also have within this the ability to mesh data together, which gives some exciting connectivity options whereby we can't get this direct line of sight that people want, but we can hop from device to device to finally reach a network that we can connect to. And we can separate these into mobile device applications, ISM band applications, and that affects really our billing, our connectivity options, and our control over what we use. So what I'm going to take you through is some of these standards within here and look at what the standards are. Of course, you're familiar with some, you won't be familiar with all of them, and I want to concentrate on really what are the most useful ones for mobile non-fixed device connectivity that are usable pretty much now. So firstly, let's look at Sigfox, which is a low power, low data rate, long range networking standard. It's been around for some 5 years. Really, it's designed for mobile assets. It's designed for wide area coverage for very low usage. And obviously the target is to have an asset somewhere remote that can report in, typically with battery power lasting anything from 2 to 10 years. Payloads are small, the number of messages per day are very small. So obviously it lends itself to very simple track and trace applications. We can get 15 kilometers or so to base stations, and network coverage depends on where you are. It being a French standard, France is very well covered. UK is becoming fairly well covered, and it is possible to actually add in your own base stations so long as you make it available to all other users. And that's an important differentiator on Sigfox. You must be part of the Sigfox network and you must pay them a subscription. So it is effectively a closed network, but if there isn't coverage, you can get in base stations and install them. The final point to note about is it's unidirectional, very small messages. Talking back to the devices is effectively not possible, but this does give the advantage that you can do roaming very easily. And if you want to roam from country to country, there's no cell handover, there's no difficult network overheads. You send in the message and the base stations around the world will pick up the message and will send it back to the Sigfox servers, and you will get access to your data. Similar in scope to Sigfox, but probably more prevalent, is LoRa and LoRaWan. Again, this is another ISM band application. Again, it's low data rate, but the capacities are larger. So we're looking at tens of messages per day with larger payloads up to, say, 256 bytes. It uses spread spectrum, and we like that because that makes the range much higher, because we use the advantage of the spread spectrum and lots of bits to encode the data to give us a much longer range, much better sensitivity, and much more robustness against interference. So we have good communication protocol that gets the data through. Again, the sacrifice comes at bit rate. So we're looking at low bit rate applications, much wider range than, for example, Sigfox would have, but still typically in the 10 kilobits a second range. Again, we've got about 15 kilometers transmissions on this. You can do bidirectional, and one of the lovely features about LoRa is you can have several devices, so long as they have different code sequences or spread factors, as they're called in the LoRaWan world, you can have several transmissions at the same time on the same frequency, and you can discriminate between them. One of the things to emphasize is that LoRa is the protocol, LoRaWan is actually the network that you attach to. So a LoRaWan network uses LoRa as a modulation protocol. And typically when people talk about LoRa, what they actually mean is the LoRaWan network that they're going to attach to. One other thing you can do is that there are public networks available to connect to, but also you can put in your own base stations, so you are in complete control of your network. And that means you're not dependent on someone providing network connectivity for you. You don't even have to pay them a subscription. You can just buy the equipment and install. And so it is becoming very popular for industrial and commercial IoT applications, whereby you can put a number of monitors, say, within a refrigerated cabinet, and you can get the message out even through the metallized walls, the insulated walls, and get that data back to your application. The next ISM band system I'd like to cover is Bluetooth. And Bluetooth really has grown up from this personal area network device that was just intended to handle my headphones and my little microphone or my headset to being much more. It operates in the 2.4 gigahertz ISM band. And that's important because that's an internationally available frequency band. So we have one version of equipment that ships around the world and that you're allowed to use throughout the world. Bluetooth itself falls into two standards, and the original Bluetooth is now called Bluetooth Classic, and we're up at Bluetooth 4 and Bluetooth 5 as being commonly available. The other version is Bluetooth Low Energy, or BLE as people call that, and that's new and intended for lower power, longer range applications. So the classic standard was designed obviously to work with audio, so we have data rates anything up to 2 megabits a second, but it's low power, it's short range, and so we expect really no more than about 10 meters. Although if you get your installation right, if you use the higher power modules, then you may be able to achieve anything up to 50, 100 meters with it. What's more exciting, I think, for factory applications is the BLE standard, which is designed for long-term battery power, longer range, and again, we're talking up to 100 meters, say. It's a much lower data rate, but for the sort of devices that are connected in on there, that sort of data rate is really quite adequate for the sort of transfer you get. And BLE applications we might expect could have several years worth of battery life in them. They also have beaconing facilities. They have the ability to just look, see, conserve power, and they have exciting sort of locational aspects built into them. Bluetooth itself, it works in the same space as Wi-Fi, but it has within it some very specific features to help it avoid the interference that it gets from Wi-Fi. It's got, adaptive power, frequency hopping, it adapts its data rates and its error corrections. So Bluetooth transmissions are quite robust. Really, what classically people are using for their mobile connectivity is cellular. And in some respects, cellular has all the appeals that you have, other than the price that you have to pay for it, because essentially most people do not want to be network operators. They want to hand that responsibility off to somebody else, and really they just have an application that they need to get data from. We've looked at where we're going from 2G and 3G, and really we're now at 4G and 5G, and we're looking at LTE, Cat1 and Cat4 typically as part of our 4G connectivity, with some really impressive data rates, say up to 150 megabits a second is possible, with ranges that are certainly comparable to 3G, and a roadmap for connecting much longer ranges through the IoT standards that are associated with LTE. So we have LTE Cat M1 and NB-IoT as IoT standards for connecting small devices at lower power, longer range, and lower data rates. One thing to be clear on this is 4G is very much here. The IoT standards are really only being installed now. So there is some availability, but it's not universal. In terms of the data rates you can expect out of the 4G and 5G standards, in terms of latency, which I'm sure if you've been following the talk about 5G standards, then really there's a standard planned for most of your applications. And depending on the class of application, depends on the standard you need. Obviously, there's no magic. If you want high bandwidths, you'll be sacrificing range, you'll be sacrificing power. If you want really low power, then it's low bit rates. It's probably going to be high latency. What you can see is that within the middle of the range, we have the standard LTE networks available now, and the particular ones, as you'll see in the bottom left of the corner, NB-IoT and Cat M1, give you some idea of data rates and latencies for your networks. 5G will push us much further out into low latency and higher bandwidths. But again, 5G really is just coming, and we're looking at the sort of connectivity options that it will give us in the future. So summing up about the NB-IoT Cat M1, the IoT networks, is they're built as part of the 5G networks, but actually they are separate technologies, and some of the infrastructure has been rolled out ahead of 5G. So you will find pockets of NB-IoT available within the UK, and certainly available within other parts of Europe, very much available within China. And you'll also see that there's LTE Cat M1 available in quite large parts of the US. The standard you use depends very much on what your network supports. Some countries are rolling out both. Europe is certainly concentrating on NB-IoT. US, we assume, is going to be LTE mostly. And we see that there are two classes of application. NB-IoT is lower power, probably longer range, lower bit rate, and that Cat-M1 will handle higher data rates and probably more connections. Don't get too excited with this at the moment, in as much as you can try your applications on these networks, but you can't be sure of connectivity. So at the moment, equipment manufacturers are hedging their bets, making sure that they can do conventional network connections on 2G and 4G, but also supporting the emerging NB-IoT and LTE Cat-M1 standards. Eventually, we expect that these will replace much of the IoT standards. They'll be lower power, lower cost, both in terms of connectivity and in terms of the equipment costs themselves. Finally, let's not forget what's coming. And really, there are some exciting, if speculative, developments in terms of satellites. So if you have a truly mobile device that may go anywhere where there's no hope of getting infrastructure, don't be bothered, because satellite direct from the modem up into the satellite receiver is coming, with the ability to mix in operation with terrestrial devices to save the cost of the satellite link. There have been services announced for LoRaWan, for cellular and internet, and we can expect these to start coming in early 2021. And this is one of the things that we at Wyld Networks are supporting, a LoRaWan direct-to-satellite connection. And I look forward to bringing information to you all on that in the near future. I'm Steve Clarke. Thank you very much for listening. If you want to get in touch, we'd love to hear from you.